in the floor level GA seating. Can you guys hear me okay? Cool. That's Addy. He's running our sound for us. Would you please give him a round of applause? My name is Int80. I'm the rapper in dual core. This talk is Moar, anti-forensics, Moar, Louise. I read online that you're supposed to start public speaking with a joke. So in the US we have knock knock jokes. I don't know if you guys have them here or not, sorry. So I say knock knock and you say who's there. So knock knock. FBI. So this is like one of my concerns. And we'll talk about this more. So you may be wondering, Moar, Louise, like, I don't understand, what is this? I don't even, so this video from Sky News, it's about the Lulz boat.
It's imploding. Europe's imploding, and he's still banging on about this.
I hate to continue about hacking though, but the latest victim to be hacked apparently is the Sun newspaper, which its website has been targeted by Anonymous, which you might remember how it was with WikiLeaks. That was before, and that's what happens when you log into it now. The Louise vote, it says. So I don't know if it's still like that.
Who's the Louise vote?
That's what it's like now, if you click on now. So
yeah, well,
it's
some hacking thing. Who is Louise vote? No.
I don't know.
Anyway, put it now,
it was called Anonymous, and they hacked into various profile companies.
I mean, it's wrong. But you shouldn't go wrong websites like that. It's not funny, it's not clever. He says, wait till I'm done now tomorrow for saying that, and the Sun get control of it back and get their own stuff.
Okay, lots more still to come, including why the Express says a closed-door policy of migration is the best way forward for British workers. We'll take a look at how...
Lol, what? It's wrong. You shouldn't be hacking. That's wrong. Alright, so, the Louise. I love when people give presentations and they say, like, you're responsible for your own stuff if you get caught, blah, 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 it's not my problem, don't use this to do illegal things, but actually just do illegal things. That's how you learn. That's how, I started by cracking software, like that's how I learned. I was going to say those other 3 bullet points, but I actually got legal advice that was, don't do that shit. That was actually the verbatim legal advice, so I won't read those other 3 things. Alright, so just kind of like setting the ground floor, like, if you are getting your stuff confiscated and you're being investigated, you're going to have a bad time. So what I'm doing, like, with this trolling stuff of anti-forensics, is trying to change it to this. If I'm the subject of your forensics investigation, you're going to have a bad time. So this is what we're going to talk about. They're trashing. Hold on, I have something for this. Okay, we're going to talk about hacking. Alright, so in trashing, we're going to be talking about trashing timestamps across file systems. Staying hidden, we're going to talk about hiding your stuff in places that you may not expect. So I've written a Python script that embeds stuff into ping files, like images, which is kind of fun. Trolling Ardor, we're going to do a lot of KeyPass and TrueCrypt stuff, messing about with KeyPass databases and TrueCrypt volumes. And then Easy Mode is just a script that I'll be publishing that lets you switch quickly in and out of Tor if you're using Proxy, kind of like anti-network forensic stuff. I don't take myself seriously at all. Like I code C and x86 all day, and this is just me goofing off. So that's what we're doing. Okay, so they're trashing. So on Linux extended 4 file systems, you have 3 attributes to a timestamp. You have your access, your modify, and your change. Right? Like we can see that if we run stat. Bam. So access, modify, and change. Okay, so everybody fine there. If you want to mess with the timestamp, you can use touch. Except that the problem is that you're only hitting your access and your modify, that change timestamp is still going to be the same. So for a beer, does anybody want to yell out a suggestion as to how we could also hit the change timestamp? Change the... Yes, Digi Ninja gets a beer. Cheers. So what Digi Ninja said was change the system clock and then change the file timestamp, which is absolutely right. So we modify the system time and update the file timestamp, and then we can restore the system time. And when you go to stat the file again, it will have changed. So demo time. Wait, is it? Yes. Oh, right. Okay. So I wrote the script just in Bash. It's called "Look at all the fields I know." Again, I don't take myself seriously. If you go on my GitHub, you'll see that like all the scripts have hilarious names. So let's see. All right. So we noticed that that this one has a timestamp of 1979. All right. And if we stat it again, it's now got a timestamp of 1991. So what this script is doing is literally changing the system date to a random time, touching the file, updating the file timestamp, and then restoring the system date. And that's all there is to it. Not a whole lot going on, just trolling. But if you're doing a forensics investigation, you're doing IR, you're looking at like what time files got accessed or used or modified around the time of an attack. And so if the timestamps are all off, that kind of throws off your investigation. So the reason that this gets demoed in the VM is because, as a bonus, you can tie in, like, look at all the fields I know. It just takes a file, a single file, as an argument, and it operates on just that single file. But you could, like, throw this into a find command and modify all the files if you wanted to. And so, for the Louise, when I did this in the VM, I got some hilarious results. Like, if you look at the dates, one process is trying to read the system date. Another process is trying to modify it to the year 1440, I guess. And another process is modifying the system date at the same time to the year 2325. So, hilarious things happen. So if you do it in serial, you can, have good accuracy. Like if you operate on one file at a time, you could, maintain your correct system date at the end of everything, and have like a bunch of modified file timestamps. But if you do it in parallel, you can do it way faster, hit all the files all at the same time, but you might end up in the year 2032 or whatever. So there's syncing to be done. The other problem that I noticed, because I like math, except when I have to do math, is that when you modify a file, notice that the nanoseconds here are all zeros. So that could be like a way to identify that a file has been tampered with. I don't know. This is kind of if you're trying to not get caught or whatever. But in this case, I would say that you're using this like time stomping. If you're already worried that you're under duress or whatever. So the other part is that I'm sure somebody has coded this somewhere else, but I couldn't find it, so I wrote it real quick. And then what was really funny was I wrote this one night, and I came into work the next day, and I was like telling one of my coworkers, I wrote this tool, LOL, whatever. And the manager in the office, he starts like talking about this investigation he's working on. Like he comes in after I get in, he starts talking about this investigation, and he's like, "Oh man, these effing attackers! Like they like change the system time, and then they like modified the file timestamp, and then they reset the system time. And my coworker's like, "Oh, David just wrote a tool that does that." And my boss is like, "Are you breaking into our clients?" No, not yet. So it actually, that happens in the real world apparently in IRL. Any questions about timestamp stuff? Pretty straightforward. Cool. All right. So staying hidden, messing with ping files. I always like to think of like random places that you can throw your stuff, right? Like you can do file inclusion attacks by putting PHP code in a JPEG, right? Like you can put stuff like everywhere and make cool stuff happen. I have one cert. It's the SANS reverse engineering malware cert. My work paid for it, whatever. So on the SANS mailing list, like if you pass your cert with 90% or higher, you can get on this mailing list. So on the SANS mailing list, somebody sent this email and they were like, "Hey, I heard something about embedding malware in ping files. Does anybody like know about this, or do you have any instances of this where I could like examine the ping file and like work on extracting the malware?" And I'm like, "I've never heard of this, but it's a ping file and you're sticking a PE in it. It can't be that hard." So I like look up ping files and whatever, and I write this tool that does this and generate this ping file, and then I just reply to the email with just this. Now, actually, in that ping file, there is malware embedded in it. But I didn't, give them context. I was just like, not sure I'm serious. So, hello, yes, this is dog, is a Python script that will break apart a ping file and embed whatever you give it. Actually, I mean, you could give it a Windows binary, you give it a Linux binary, whatever you want to do. So the way that ping files work is they break down into two categories of chunks. There's critical chunks and there's ancillary chunks. Critical chunks you actually need to properly render the data. That's like your actual, for real image data. Ancillary chunks are just metadata, sort of, if you will. So if your program that's rendering ping files goes to process some ancillary chunk that it doesn't understand, it just is like, fine, whatever, don't care, and moves on. So literally, zero fucks given. You can put whatever you want in an ancillary chunk, including Windows executables. So, so that's it's like a stage N, anti-forensics thing, right? Like you've already compromised the system, you're just hiding your malware somewhere. So I was like, okay, well, how do I go about beating this? So one of the issues is you're just sticking a straight PE file into a ping file. So literally, if you look for the MZ header, you will find it. Bam, there's our MZ header. Everybody knows the Windows PE. MS-DOS stub starts with the hex bytes 4D, 5A, MZ. So literally, if you start extracting at this offset where the PE header starts, you can pull out the malware. So it's trivial to find that if you wanted to. So that's one of the problems, right? One of the ideas that I had is, which this script does, is you can split the file. That way you don't get a single contiguous extraction of your malware. So hello, yes, this is dog has an option to split your embedding file. You can also transform it with a one-time pad or a key, so you could generate a large random amount of data, use it as a key to XOR across, and therefore encode your file that you're embedding. So another problem that I thought it might have is, what if you just have this large chunk, right? You're creating this ancillary chunk inside of the ping file. So if some forensics tool looked and was like, oh man, this has some abnormally statistically large chunk in it, ancillary chunk, you might be found out. So hello, yes, this is dog can also randomly select how many ancillary chunks it wants to use, and it can also generate a random size for each chunk. And so that way you never get like the same output if you wanted to operate that way. And then another problem was with ping files where people were sticking PEs in them is they generally just stick it at the back. So like quick statistical analysis would say like, oh, like here's a ping file with a large ancillary chunk at the back of it. Probably bad. You know, even if it was like an encoded PE or whatever, like some kind of encrypted data, you could just say like, you could flag that that's some sort of anomaly. So, hello, yes, this is dog, can rebuild and reorganize the ordering of the chunks. It doesn't matter to the ping rendering application, like in what order the chunks appear, because it's going to process all the data, so you can order them however you want. So basically, I just try to be as random as possible, /v/ and make it, you know, tougher to derive like a consistent uniformity across what's happening. Again, this is stage N. This is like after you've compromised the system, whatever, but you're hiding your stuff. You're keeping out of the way from forensics investigation. And the bonus is that the host file still displays as a normal image. So that's kind of cool. For a beer, what kind of dog is in the picture of hello, yes, this is dog? Yeah!
Round of applause, please.
Yes. Yeah, you can be BruCON staff and still win. Hello, yes, this is dog. Okay, so another thing that I considered with anti-forensic stuff is like the keys to my kingdom, right? You know, like I don't know any of my passwords. I don't like actually retain a lot of my files in plain form. They're in TrueCrypt volumes. You know, my passwords are in a KeyPass database. So what I don't want to happen is for a forensics investigator to be able to extract my TrueCrypt database or my TrueCrypt volume or my KeyPass database and crack it, because then they get all my stuff. So TrueCrypt has a documented header, just like a lot of file formats do, and it uses the information in the header in order to operate correctly on the volume. So you can actually just like crush a TrueCrypt header and render the volume useless. So I wrote this patch for TrueCrypt, and basically, if you type in the wrong password, it destroys your header on your volume, thus making you unable to render or decrypt the volume. Did anybody see my DerbyCon anti-forensics talk? Folks. Okay, so I did a kind of a similar thing, but with MBR, the master boot record on a system. So basically, like I boot off of separate media, like a USB drive. Therefore, I don't need the MBR on a hard drive. So if you boot off the hard drive, like if you're a Fed and you don't know what's going on, you try to boot the hard drive, it wipes the hard drive. Like the MBR that I wrote wipes the hard drive. So kind of the same thing here, right? Like the situation is like maybe you're going through the airport and the TSA is giving you a hard time, and they want you, you know, they've pulled out, I don't know, like a USB drive or something that has a TrueCrypt volume on it. They want you to decrypt it. These things happen. You could like effectively clear your TrueCrypt volume without them actually knowing that that's happening. So let's tempt the demo gods again. Okay. So basically, what we're doing is running TrueCrypt on this volume that I have, root.tc password is Tor, and then we're mounting it to the TC directory. And if we look in the TC directory, there's my stuff, private. So just proving that, you know, this is an actual TrueCrypt volume, it works, whatever. Okay, so if we run my modified TrueCrypt. And it asks for the password, normal operation, right? And I typed in the wrong thing. Everything looks normal, right? It's just prompting for the password. But if we take a look at the header, the TrueCrypt volume, it's kind of been modified a little bit.
Oh, just a little.
So, and you know, all of that operation looked normal, right? Like, oh, I accidentally typed in the wrong password. Oh, now it won't decrypt. This is the patch. Very simple. I'll push it up to GitHub. Basically, it just checks to see if an incorrect password has been entered. Grabs the path of the TrueCrypt volume, and then opens the file for binary file I/O. We pass in iOS in and iOS out ORed against each other so that we can overwrite in place. If you just do iOS out, it will truncate the rest of the volume, which could be fine also. I mean, you can do that, no problem. See to the beginning, because we're going to overwrite the header, and write in 512 byte blocks, and then, of course, close the file, because we're good programmers and we're clean. Has anybody read Bug Hunter's Diary? It's a book by No Starch. It's kind of cool. One of the reasons that I like it is the author starts with like, oh, I was looking at this software, and then gives you like the anecdote of his whole like process into how he went from finding a vuln into writing the exploit. Kind of the same setup here. Like what I started with was just looking for the string, enter password for. Like if you want to modify TrueCrypt, this is kind of how I did it. Because that's what prompted me, right, for the volume. And then from there, I was able to quickly find the source file that we're going to be messing with, and then modifying, like just looking in the code, following the code flow, and just looking where to insert my patch. A couple things if you want to mess with TrueCrypt and compile your own copy. You need PK or PCKS11 headers, so you can grab them off this FTP site. In Linux, you'll want this environment variable for the include path, so just be sure to export that. A couple packages that I need to install through Aptitude, the LiveFuse headers, package config, and libwx base. I was compiling the console version, but it still wanted the WX stuff, whatever. So just some other things. And then if you want to debug it, if anybody likes to use GDB, these are some flags you can push in. The no strip flag to the make file will leave the symbols in there and not strip them out, so that way you can quickly set breakpoints and find yourself in the disassembly while you're debugging. Does anybody have any questions? Yes? So the question was, you know, this isn't very stealthy. Any options for being more stealthy? And yes, if you did not want to be as obvious, instead of writing trollololo over the header, you could just generate random numbers and overwrite them as well. Because if we go back to the format, you see that a lot of these are just encrypted, right? So there's no way to tell, like, is that D word at offset 64? Like, you know, is that the right set of bytes or no? So like, yeah, you could just generate random numbers and overwrite them in the header as well, and that would be more stealthy. So yes.
I'm sorry, you're just overwriting the file once. Shouldn't you shred it first? Or shred, I mean, you know. Yeah.
Yes, so the question was about overwriting just one pass on the TrueCrypt header. I guess, you know, if you were concerned about like electron microscopy being conducted on the actual platter, then yeah, like you could do multiple passes as well. Yeah, that's a good question. So the other thing that I'll mention is, you know, this only works when you're kind of doing it live, right? You know, like in an actual forensics investigation, in most cases, like if your stuff got seized or whatever, like this gentleman pointed out, you would be operating on a copy. Like the forensic investigator would be operating on a copy, so they would not have your modified TrueCrypt binary. They would have their own, you know, TrueCrypt binary, which you had not patched unless you had lead hacks. So you guys might be wondering, like, you know, what's up with this? Like, what's your problem? Like, why so paranoid? So, you know, you probably won't need any of this ever, and hopefully you won't, because forensics sucks. But, you know, the Patriot Act is pretty invasive, I would say. You know, we're more and more subjected to administrative searches, in the US at least. I know that Europe has some better aspects about being about privacy. So this is like my story as to like why I'm somewhat paranoid. I got out of college at the end of 2005. So 2006 I started going to 2600, that hacker group in Cincinnati, and it was me and one other guy giving like all the talks for a long time. His stuff was all network stuff, doing cool ninja stuff. Mine was writing exploits and like breaking into stuff, but not doing anything illegal. Just like, you know, here's this VM I set up, and, you know, like here's how you write this exploit, whatever. So I found out like after that in 2003, these two guys from Cincinnati that were involved with the 2600 group had been arrested by the FBI for doing illegal computer things. So I was like, you know, kind of like, I'm sure there are FBI folks coming to our 2600 meetings. So I go to an InfraGard, which is a FBI outreach program in the US, and you know, I'm like, what do these guys know, whatever, like I want to find out like what they do and how they do it. So I go to the first meeting, and like I'm leaving, and they're like, oh, we have this new cyber special agent, his name's Dan, blah, 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 and like I'm on the way out, shake his hand, like, hey, I'm David, nice to meet you, and I leave. Like 6 months later, I'm at a baseball game, and the FBI bros are there, and I'm like, oh, hey, what's up, like, I met you before, but I don't remember your name. And the guy's like, I'm Dan, and he's like, you're David, right? And I'm like, yeah, and then he says my last name, and I'm like, whoa, not cool, I did not introduce myself that way. So that was kind of crazy. And then a couple years after that, our neighbors across the street moved out. This is when I lived back in Ohio. Our neighbors across the street moved out, and I went to go say hi to the new neighbors, and it was the cyber special agent from the FBI. Yeah, please don't clap. That's fine. So yeah, it's like this. So we had a forensics group inside of InfraGard, digital forensics, and at the time I didn't know anything about forensics other than just fundamental stuff. So I was like, what do these guys know? I want to know like how good they are, whatever. So I started making forensic challenges, like just like we do CTF, we do crack knees, like, you know, if you can like capture all the flags, you win the forensics challenge. And then the rule was, if you win one, you make one. So I made the first two to get us started, and we did it for a little over a year. And the FBI bros won 0 of them. They didn't win any at all. I won some, more than 0. So this is all like kind of like warning shots, like please don't come take my stuff. Like I just want to keep all my servers up. If I'm the subject of your forensics investigation, you're going to have a bad time. Cool story, bro. Okay, any questions about the TrueCrypt patch or my hilarious backstory with the FBI? Yes, in the front.
mentioned before with the TSA, is it really necessary to delete your data for a security guard at the airport? In TrueCrypt, isn't there a dual password possibility? So one password leads to your data and the other leads to a distraction, some pornography or something to keep them busy?
Yeah, but you bring up two good points. Number one, who in here thinks a TSA agent actually knows what TrueCrypt is? But number two, right, so there are hidden volumes, right? So like I could, put in one password and just be like, oh, this is my horse porn, how embarrassing for me. And then like all my other stuff is in a separately hidden volume. Absolutely. One of the issues I think would be that if I have a volume that's like, let's say like 2 gigs in size arbitrarily, if I put in a password, I have a hidden volume that's 1 gigabyte in size. When I decrypt the public side with the horse porn, that's just going to mount the volume and show that it's 1 gig, I think. So they would say like it's a 2 gig file, but you only have access to 1 gig. There's something else that you're not decrypting. Possibly. Yes. So the question is about constitutionality of being compelled to decrypt your encrypted data. And in the US, to the extent of my knowledge, that's still kind of working its way through the system. I know there were a couple cases, probably the most relevant one of recent is out of Colorado, where a woman had a laptop that was completely encrypted, and she was the prosecution was trying to compel her to decrypt her system. And the argument in the US is a Fifth Amendment, compelled self-incrimination. There is no official ruling yet from like the Supreme Court that says like, no, you do not have to provide your encryption key, or yes, you do. To my knowledge, I don't think that there is, but also the TSA is not law enforcement in the US, which is different than customs or like a police officer, for example. So they don't necessarily have to my understanding at least, they don't have to follow the Fourth Amendment laws or whatever. But again, the first 3 bullet points. Sorry, I'm just a nerd. I spend all day in IDA and I make rap music. So, does anybody have our new album? Just out of curiosity. I love you guys. It was the #1 selling album on Bandcamp when it came out. And it was on what CD, like within an hour after it came out, private tracker on, yes. Anyways. Alright, so KeyPass databases. Anybody here ever carve files, do forensic stuff and carve files out of disk images? One. Okay, so when you're carving files, what you're looking for is the magic number or the header bytes to determine like what kind of file you're carving. So JPEG has its own header bytes. GIF 89A has its own header bytes. PNG files have their own header bytes. This is the header bytes for a KeyPass database. So if you had a drive image of my hard drive and you wanted to extract the KeyPass database, you would look for those bytes and then start extracting from there. So I wrote this patch for KeyPass. I call it isDolen, and it just basically uses different header bytes. It's a custom version of KeyPass, just sort of like a custom version of TrueCrypt. But that way, without reverse engineering my copy of KeyPass, you won't know what the KeyPass header database bytes are, and that way you can't just carve out the KeyPass file. So this is the patch, literally like 2 lines. For a malware analysis book, free of charge, from No Starch, shipped from the US, and signed by the author Mike Sikorsky, who's actually here giving a workshop on machine learning. Does anybody, first person to come up with what the DB sig is, the new one, gets a copy? It's ASCII printable. The hex bytes are ASCII printable. What? Nope.
Trollolo.
Yes, who said that? Yes, in the back. It is trollolololo. Round of applause for the gentleman in the back. Well done.
Das wäre meine Antwort gewesen, ich habe mich nicht getraut.
Shoot, I gotta get another book now to give out at Derby time.
That was actually the answer I was thinking about giving, but
Let's see.
kind of
Probably.
like, no, what happens if I'm wrong? Well, it was competitive, so something like that.
So this is my normal KeyPass database, and you can see that the header bytes 03, D9, A2, 9A, blah blah blah, just like we saw in the earlier slide, 03, D9, A2, 9A. Cool. So you could easily carve that out. But my modified KeyPass database has that header bytes. So if you're a forensics investigator and you're just letting NCase do its carving, or FDK, or Scalpel, or whatever your tool of choice is, it's going to cruise right past these bytes, not see a normal KeyPass database, and therefore not extract the KeyPass file. And if they don't have the KeyPass file, then they can't crack it. So a couple caveats with this. Timestamps, not immune to normal IR stuff. So if you're looking at like, oh, KeyPass was run on the system at this time, and this file was accessed or modified at this time, it's going to show up. Don't name your KeyPass database with the normal extension. That would show up in a regular listing as well. KeyPass has a setting where you can set your favorite file, like, oh, this is my normal KeyPass database that I use every day, and it will remember that for you so that you don't have to load it each time. But if you set that, then they could use that copy of KeyPass to find what your KeyPass database is. And if you throw KeyPass into a debugger or a disassembler, like the awesome IDA Pro that I love so much, you can easily see that this is the new header. These are the new header bytes for KeyPass. So I'm just kind of trying to, I don't know, make it a little more difficult for forensics investigators. I'm not lead hacks or anything. Okay, more TrueCrypt volume stuff. So I was asking some forensic bros that I know, how do you find TrueCrypt volumes when you're doing investigations? And they had two ways. Number one is take the entropy of a file. That's the measure of randomness of the bytes. And number two is to check the file size. Large files are more likely to be TrueCrypt volume candidates. So entropy is obviously going to stand out, right? Because it's encrypted data. It's very random. If you have all ASCII printable text or all zeros, not that random. So I did some testing on my own. I'm not planning to publish this source, but if anybody wants it, just hit me up and I'll happily send it to you. I generated over 9,000 TrueCrypt volumes of random sizes, copied in random contents, and then took the entropy of each of them. And it was through the roof. Statistically, the only thing I can think of is maybe I did the wrong type of entropy, like I did Shannon's entropy, which is what we use on PE files to try to determine if they're packed or not. Maybe I should have done a different statistical test. But anyways, huge entropy, right? So I'm like, all right, this is gonna stand out, obviously. If you take the entropy of every file that you pull out of a drive, it's gonna stand out. So I was like, okay, well, I'll just reduce the entropy, no problem. So I do that by introducing non-random data. And what's awesome is, if you remember from before, with the TrueCrypt header, all of these members of the data structures associate to aspects of the TrueCrypt volume. So you can throw whatever you want at the back of your TrueCrypt volume, and TrueCrypt just does not care. It's totally fine. Kind of like with the ping files, oh, I don't need this, whatever. Same thing with TrueCrypt. Same thing with a lot of file formats. It uses the internal data structure to say, like, you know, I only need to read to this point. So we can therefore just throw like tons of non-random data at the TrueCrypt volume at the back of it. It still decrypts just fine, and the entropy is going to be much lower. Alright, so what's this box, please? And this isn't even really worth publishing. I may not push it up to GitHub, but it's just a DD command, right? So we're just writing a random amount of zeros to the back of the TrueCrypt volume. You guys trust me that that's, you know, the root.tc password is Tor, that's a TrueCrypt volume. I just copied over the original. Okay, cool. So we'll write a bunch of zeros to the back of it, 540 megs worth, and decrypt it just to prove that it still works. Oh shit, I overwrote the original. True, yeah, thanks Robin. And there's my stuff. Right? Alright. And if we just like dump all the hex, might take a bit. Anyways, we should just see like a bunch of zeros at the back of it, if it ever, we'll come back to it. But it doesn't have to be zeros, it could be anything that's not that random, like base 64, easily, like whatever you want to do, just not random data. And what we're doing is reducing the entropy so that it doesn't stand out. So if you were, you know, how do I find this? Two problems. Number one, you have a file with a bunch of random data and then non-random data, right? So you could profile that, I guess. And then also you're increasing the file size, which was one of the attributes that my forensic pros talked about in finding TrueCrypt volumes. But we'll talk about that later. Oh, damn it. Anyways, okay. So, continuing with our trolling. Alright, so if you're conducting an investigation and you're like, hey, I found KeyPass on this system, but I can't find a KeyPass database, that might be a red flag, right? So one idea that I had was hide a KeyPass database that isn't actually a KeyPass database. So I wrote the script, OP will deliver. It generates a fake KeyPass database with the normal header bytes, creates an archive, encrypts the archive with a very easily crackable password, and then embeds, you know, you have the KeyPass database with a fake key file inside of that archive. So you kind of like lead them along, like lead the investigator along. For our password on the archive, we're just using the American English Insane dictionary. You can install it with aptitude. You specify what you want to call your archive, your KeyPass database name, your key file that you're, generating, and then we're going to also throw in a copy of KeyPass inside the archive, so that way the investigator thinks like, that they're onto something and hopefully waste their time trying to crack a KeyPass database that isn't actually a KeyPass database. So this is just our function that creates the archive, selects a password from the word list, copies in a copy of KeyPass, and then randomly decides whether it's going to do 7-zip or RAR to make the archive, and then shreds the original key file that it copied in, and the database. Does anybody know, for a beer that I will buy you afterwards, does anybody know why I picked either 7-zip or RAR and not something like zip? No, for the archiving archiving format. Close. So the reason is, in a zip file, even if you password protect it, encrypt it, you can still see the files, file names, like the content listing of what's in the zip file, even if it's password protected. But with 7-zip or RAR, you cannot. So that way, like, they don't know what's in the archive. Okay, so these are the header bytes for normal key pass. Remember, we saw those on the slide earlier: O3, D9, A2, 9A. We write the header into a fake key pass database, stick a bunch of random data on the end of it, create a fake key file, and archive it. I'll get you a beer though afterwards. I love participation. So again, we're leaving a trail, right? This isn't our real key pass database, but we're just basically spinning cycles for the forensics investigator, like making them waste time. Forensics investigations are very resource intensive, time intensive, like it takes time to do all this stuff. So we're giving them busy work to do that actually doesn't get them anything. Okay, so same thing with the key pass as with TrueCrypt. We found a copy of TrueCrypt on the system, but because of my use of box please, the entropy did not make obvious a TrueCrypt volume. So just like we did with the key pass, we hide a fake volume in an encrypted archive. It's pretty much the same code, except I call it UMAD bro. Same thing, leaves a trail. Now they found TrueCrypt volume. Any questions about that stuff at all? This is my last thing. So I like to use Provoxy for browsing. You can easily point it at a local SOCKS forwarder. So whether you use SSH to set up a local SOCKS listener and then browse out through an encrypted SSH tunnel, or you use Tor. Provoxy is great for that. But I actually do both of those things, and I got tired of opening the Provoxy config, setting it to to go to Tor. To go to Tor instead of my SSH listener, SSH tunnel, and then restarting Provoxy. So I just wrote the script that automates that for me, and I call it "Did someone say Spider-Man thread?" So what it does is it pushes the current SOCKS setting in Provoxy, just stores it off locally, switches it over for you, and then restarts Provoxy. So just automates all this. You can also set an alias to make it a little more obvious. So you're like, what WTF is, did someone say Spider-Man thread? Or the arguments or whatever, you can just set this alias and it makes it easier. So those are, you give it your Provoxy config, give it a directory to just store the local setting. It will go to ifconfig.me to grab your local IP and or your externally facing IP and let you know that it's done that. So actually, see you. Okay, so my current SOCKS setting through Provoxy is to browse through 8080 locally. Oh, lols. I don't have my SSH tunnel up, that's why I was getting angry. Or maybe I did. Oh, internets. Anyways, it pushes your local setting, switches it over for you, so you can start browsing through Tor. And then when you're done, you just use the stop using Tor alias, and it will restore your original setting. And that way it's one command instead of having to go manually do all those steps on your own. Aliases. Some other ideas that I had for stuff to mess with. Log tampering is always fun. So I haven't seen any Windows tools that do log tamperings. So that might be something to mess with in the future. I know of Linux ones, but you know, if you mess with the logs, like replace your IP with some other IP, or set new events or whatever, or remove events, that can always be good because you can lead IR investigators or forensic investigators the wrong way. Compression lulls, like has anybody seen 42.zip? A couple folks, awesome. 42.zip is basically like a file that's all A's and then compressed, and like it's just like once you decompress everything, it's like tons and tons of gigabytes, but it's a very small zip file because it's uniform text, so no entropy, so it compresses very well. You can do stuff like that, messing around with compression. Also, PDF streams, you can do all kinds of hilarity with compression of PDF streams, so that like a PDF file like expands huge into memory. I don't know if he's here right now, but Didier Stevens has done a lot of PDF stuff. Check out his stuff. And then there's all kinds of fun to be had with reversing on Windows PEs. You can do all kinds of hilarious stuff that will mess up forensics investigation. And as a bonus, you get anti-reverse engineering out of it as well. Especially if you're like pulling stuff out of memory and using something like volatility to like reconstruct the PE files. I'll be pushing all my source up to GitHub. That's my GitHub. It's got my stuff from last year on there, along with some other stupid stuff that I've written. Feel free to fork it, do whatever you want to it. I don't know if there's like a 0 fucks license or whatever, but really whatever you want to do is fine. There's a really cool paper online called How to Exit the Matrix. I think it was like published in maybe 2005 or 2006. I love to just go back and like randomly read it from time to time. It moves around between different servers, so just Google it, like How to Exit the Matrix, and it's about anti-forensic stuff, network mostly, but some disk stuff also. That's my Twitter. I'm at DualCoreMusic, DualCoreMusic everything online, DualCoreMusic.com, Facebook/DualCoreMusic, YouTube/DualCoreMusic, DualCoreMusic@gmail. Hit me up if you have any questions or rants or whatever, or if you pirated our music and you really like it, that's also cool. And then the best resource of all, Sky News computer security experts, the Louise boat. Any questions or anything like that? Yes.
They previously used Tor button to switch between states, non-Tor and using Tor, but they stepped away from that because it's terrible to share state with a Tor profile and a non-Tor profile. So why are you using this proxy tweak to turn off Tor and to turn on and off Tor?
I use proxy for like some additional like ad blocking stuff. And so that's why I browse through proxy. You don't have to browse through proxy. It's just like since I browse through it, that's why I have it.
Yeah, but you're turning on Tor through it. So.
Right. No, what I'm doing is I'm pointing proxy at the SOX listener for Tor.
Yeah.
The Tor process is already running.
Yeah, but you have a browser that's having state of a non-private state. So when you switch on Tor, you're sharing that browser state with your Tor profile. So you're not being anonymous when you're switching on Tor. By default I run Chrome in incognito mode. So are you talking about like stuff that's already like in the memory space of the browser process, or? You remember that Tor button with?
Yes. Yeah.
They stepped away from that process because it was terribly dangerous. They couldn't fix all the Firefox bugs that had having shared state between private and non-private profiles.
I think that in the case of Chrome, each browser has its own process, whereas in Firefox, I feel like each tab has its own process, whereas in Firefox, I think each tab had its own thread. So it's shared in the process space. I'm sorry if I'm not answering your question correctly, but I feel like if you have process separation, then whatever profile that you have running in one context of a particular tab should not bleed over across the other processes.
Yeah, you hope. Okay. Yeah.
Right.
So we've got time for maybe one or two more questions.
Okay.
Any more? No one? Really?
Yep.
Just regarding the whole tour thing, I only recently discovered last week, I think it's been out a couple of years. Sorry.
Pretend you're a rapper. It works for me.
I discovered last week that there's WRT routers open source available that just use Tor and nothing else. I don't know how that would clash with using different browsers, different sessions behind a single-use router like that.
I guess it wouldn't matter because that would be your gateway out into the internet. So you wouldn't have to do anything application side. All your network would be, all your traffic would be routing directly into Tor from the point of the browser, or from the point of the router. I'm sorry. So if you had Tor running on your router and everything was kicked into the Tor network, you wouldn't have to do any additional configuration with browsing. It would be transparent on the user side, on the application side.
I guess you'd probably still want two routers though.
One more question? Anyone? No one? If you've got questions, ask them later, but pay them with beer. In Zadie, everyone, round of applause.
Come to the party tonight. We'll do raps and high fives. Drink all the booze, hack all the things. Thank you guys for coming. I love you.